Hello. Today we're working on the seventh and last activity in the variables chapter of Learn to Code 2. This activity is titled Collect the Total. And in this challenge we're supposed to collect a randomly determined number of gems represented by total gems. If you remember from last time, we learned about this idea of a constant. And the key word that lets us tell whether something is a constant is let. So we say let, and then we give the constant a name, and a constant is just a container that holds a value, but in this case the value can never change. In a variable, the value can change, but not in a constant. So total gems here is a constant, and it is going to be assigned or initialized to a value that is contained in random number of gems. And if we run this code a few times here, you'll see that as each time we run it, we get a different random number of gems somewhere along the path that this character has to travel on. So in this case we have 3, the last time we had 8, and notice they can appear anywhere in any of these white wireframe gems here. And they also, it looks like they may just keep appearing over and over and over again. So we need to think about this a little bit as we travel along, how we want to handle this. So hopefully you've watched the last few videos, because in those videos we developed a really nice function a few different ways. It was this idea of just wandering along a path, collecting gems and toggling switches, and any time we're blocked we check whether we want to or whether we can turn left or right. And this path, it looks like all that work's going to pay off here in this puzzle, because this is exactly what we need to do. We need to wander along this path until we're blocked, and then we either need to turn left or turn right, depending on if the path turns left or right. So if you haven't watched those, it's really worth going back and checking out those videos. We will create something in here again similar to that, but this one will make it a little bit different. Each time we've done it a little bit differently. All of them are fine. It's just, whatever mood you're in at the time. And I like to, challenge myself to write something a little bit differently each time. So if you wrote it one way last time, don't just go back and copy and paste it. It's a good idea to practice and maybe change it up a little bit. See if you can make it better or at least different. So we have this variable or constant total number of total gems, and that tells us the total number of gems we have to collect. Now again, I like to always ask myself, what kind of things do I need to keep track of here? And I think the only thing we'll need to keep track of are maybe the number of gems that we've collected up to a given point, because while we're keeping track of that number of gems that we've collected, once that number that we've collected is equal to the total number of gems, we can stop. Okay, or another way of saying that is, as long as we haven't collected enough gems to be equal to total gems, we should keep going. Okay, so I'm going to go ahead and put that in here as a main program. While, or as long as the number of gems collected is less than total gems, we want to keep going. And last time I called the function wander. So wander collecting gems. And I'm also going to, I think, make this a little more general and have it be that even though we don't have any switches in this puzzle, I'm going to go ahead and write this function so that he collects gems and toggle switches. So that maybe sometime in the future we will have a puzzle where we need to do both, collect gems and toggle switches, and that will be a little more useful then. So wander collecting gems and toggling, something like that. Okay, now a couple of things we don't have yet. We don't have this variable number of gems collected, and again that's going to represent the number of gems we currently have. So every time we collect one, we're going to increment number of gems collected. So var number of gems collected will be set at the beginning or initialized to 0 because we haven't collected any gems yet. Okay, and then this function right in here, this is a long function name, so I'm going to copy that and write it in here, func, and paste it. And we'll get started on that in a minute. So what does this do? Well, in the past, what we've done is we've checked if we're on a gem and we collect it, and then we've checked if we're on a closed switch and then we toggle it, and then we also check if we're blocked. And if we're blocked, then inside of that we say, well, can we move to the left? Are we blocked to the left? And if we're not, then we turn left. And are we blocked to the right? Then we turn right. If we're not blocked to the right, then we turn right. And then we move forward. Okay, so I think I'm going to try to write this a little bit differently this time. I'm going to put the move forward at the beginning just to see if we can do that. So I'm going to move forward, all right, because I don't think any gems pop up on this very starting point right here. So I'm going to move forward, and then after we do that, let's go ahead and check if we have any gems. And last time we just wrote the code right in here, but I'm going to maybe put that in a function. So func check for gems, and inside here is something we've done quite a bit. We say if or is on a gem. If that's true, then we want to collect the gem. Okay, now what else do we want to do in there? If we're on a gem, we want to collect the gem. And what else we want to do in there? Well, we need to make sure that our number of gems collected is incremented. So number of gems collected, and we learned last time that we can use this syntax right here to bump up the value by 1 for number of gems collected. Okay, all right, so there we're going to move forward, and here we'll check for gems and collect them if we find them. I think I would also like to check for switches in here, and I'll write another function in here, func check for switches. Okay, if we check for switches, that's just going to be if where is on a closed switch is true, then I want to toggle open that switch. And even though we don't need to keep track of this, let's go ahead and do a parallel thing, or do a similar thing to what we're doing with number of gems collected. Let's make a variable that keeps track of how many, just because we can, how many switches we toggled. So number of switches toggled. And we'll assign that at the beginning to 0 because we haven't toggled any switches. And then right after we toggle a switch inside this function, we will just say number of switches toggled, increment it by 1. Add 1 to it each time we toggle a switch. Okay, so even though we're not, we don't need to keep track of switches in here, I'm doing that because I want this function wander collecting gems and toggling to be as general as possible so that we can use it in a puzzle where we do have to wander around collecting gems and toggling switches. Okay? All right, so we're moving forward. Then when we're on the new tile, we're checking for gems and collecting them if we need to, and we're checking for switches and toggling them if we need to. Now, we need to watch out for the next time we call wander collecting gems. We need to get ourselves set up, because if we're blocked now, after we move forward, if we're blocked, then the next time we try to move forward, we'll possibly fall off the edge, right? So before we end this in here, I want to check if we're blocked, and if we are, I want to turn left or right if we can. Okay? So in here, we'll say if is blocked, if we're blocked, and then if we're blocked, I want to have the cases where we can turn to the right. So the way to check if we can turn to the right is to say if we're not is blocked to the right, then turn right. Okay, and then also if that's not the case, if we are blocked to the right, we should check else if we're not is blocked to the left, then there's an opening or an open path to the left, and we can turn to the left. Okay, that's good for now. I think we're going to have to modify that in a little bit, but let's keep it like this for right now and just review what we have here. So our main program is just a while loop that says as long as our number of gems collected is less than the total gems, we want to keep wandering around collecting gems and toggling along this path. And if we write this function wander around collecting gems and toggling well, that should take care of it, because we'll just keep moving forward, checking for gems and collecting them, checking for switches and toggling them, and then before we end the function, we are checking if we're blocked, and if we're blocked, we're seeing if we can turn to the left or turn to the right so that we're ready to go the next time this is called. Okay. So let's give this a try, and we'll run our code here and watch what happens. Walk our way through it. So we have to collect 7 gems, and there are 4 here. So he's moving forward, checking for gems and switches, and collecting the gems if he sees them. It's looking good so far. This portal will take him over here. Not a problem. He moves forward. He has an opening to the left, so he turns to the left. He still keeps going. Move forward, check for gems, collect them. If he's not blocked, he keeps going. Now notice some gems have popped up behind us here. Uh-oh. Yeah, what's going to happen here? All right, he's trying to move forward. He's trying to move forward even though he's blocked. So why is that? Okay, let's stop this and let's think about this for a minute. So when he's on this tile, he moved forward to get onto this new tile here. He checked for gems, he checked for switches, and he asked, am I blocked? Okay, and he is blocked, right? So when he's blocked, he checked, am I blocked to my right? Is he blocked to his right here? He is, right? There's a cliff to his right, so he can't turn right. Then he checked, am I blocked to my left? If I'm blocked to my, and he is blocked, he checks, is he not blocked to the left? Is there a path to his left? And there isn't. He's blocked to his left too. So he's blocked both in the front and to his left and to his right. So none of these things happened. The turn right or the turn left did not happen. So this if statement ended. It ended, and he came back down here, and he called wander collecting gems again, and he tried to move forward from where he is. Okay? So even though we're inside this if we're is blocked thing, we did not take care of every single possibility that could happen when you're blocked. We checked if we're not blocked to the right, and we handled that case, and we checked if we're not blocked to the left, and we handled that case, but we did not check the case where he's blocked both to the left and the right. Okay? And now thinking about this, what do we want to do here? What do we want to do if he's blocked both to the front and the left and the right? Well, he's got to go get these gems behind him, right? So maybe a thing to do in that case is to turn all the way around and then keep going, wandering around, collecting gems and toggling. Okay? All right, so to do that, well, we're inside our if we're blocked, right? And we checked here, are we blocked, are we not blocked to the right? Else if are we not blocked to the left? Maybe we want to do all other cases here. For every other case, even, for every other case, if we are blocked to our right, and we are blocked to our left, and we are blocked to our front, then every other case, we just want to turn around. Okay? So I put in an else thing so that every single case is accounted for. We're either not blocked to our right or we're not blocked to our left. And if neither of those is the case, then we're going to do what's in this else clause, which is just turn around. Okay, so let's come up here and we need to add our turn around function. Func turn around, and turn around, we can just call that a turn right and a turn right. All right, let's walk through this one more time. This is a fairly detailed function here. Even though we took parts of it out, we abstracted the idea of check for gems. So we're going to move forward. We're going to check for gems, and if there's a gem, we're going to collect it. We're going to check for switches, and if we're on a switch, we're going to toggle it. Then before we leave this function, we're going to check if we're blocked. And if we are blocked, we have three different cases. One case is we have a path going off to our right, in which case we'll turn right. In the other case, we're not blocked to our left, so we'll have a path off to our left and we'll turn left. But if neither of those is the case, then we want to turn around. And that's going to happen when we're both blocked to the right and blocked to the left. So we'll do a turn around there. Okay, let's try this out here. I'm going to do a step through my code. And we need to collect 7 gems, and there's 1 right in front of us. So we called wander collecting gems. We move forward. We check for gems. We are on a gem, so we collect it. We check for switches. No, we're not on a switch. We check if we're blocked. We're not. Oh, he's done with just the 1. So let's try running this again with a little bit more complicated. Here, 8 now. We need to do 8. Okay. So while number of gems collected, it is less than the total gems. We're checking for gems. We are on a gem, so we collect it. Now we check for switches. No, we're never going to be on a switch, but it's nice that it's in there. Now we call wander collecting gems again. He moves forward. He checks for gems. There's 1 there, so he collects it. He checks for switches. There's none there, so he doesn't do anything. Then he checks, is he blocked? No, he's not. So he can call wander collecting gems and toggling again. Moves forward, not on a gem, not on a switch, not blocked. So he'll call it again, wander collecting gems, move forward, check for gems, check for switches. This time we are blocked. So we're going to see what we do here. We're blocked, but we have a path off to our right, so he can turn to the right. Now he's set up to move forward. I'm going to take the portal over. He's going to move forward. Checking for switches. He's going to call wander, move forward, check for gems, check for switches. There aren't any. He's blocked to the front, but not blocked to the left, so he'll turn left. Good. He can call it again, move forward. Check for gems and collect it. This is our 3rd one. Now we'll just keep doing the same thing here. Move forward. He's on a gem, so he'll collect it. Not on a switch. Not blocked. So he'll call wander again. Move forward. He is on a gem, so we'll collect it. There are some gems behind us, so hopefully we'll turn around here pretty soon. Get to check that part of our code. We're not blocked, so we call it again. Move forward, check for gems. There is none. Check for switches. There are none. This time we'll be blocked all around, so he's going to call, hopefully, turn around. And there it is. He calls turn around. Good. And now things should work out just fine. I'm going to move forward, check for gems. He is on a gem, so he collects it. Bump up the value of number of gems collected. Call wander, move forward, check for gems. There are none. Check for switches. There are none. He's not blocked, so he's going to call wander again, move forward. Check for gems. This is the 7th one. Collect it. Check for switches. None. We're not blocked. so call wander. Wander moves forward. Check for gems, none. Check for switches, none. We're blocked, but we are not blocked to the right, so we turn right. Call wander, which is a move forward. Take the portal over. Check for gems. Check for switches, none. Not blocked, move forward after we call wander. Check for gems, none. Check for switches, none. This time we're blocked, but we're not blocked to the left, so we turn left. We call wander, which is a move forward. We check for gems, none. Check for switches, none. We're not blocked, so we call wander one more time. We move forward. We check for gems. We've got one. We collect it. That's our 8th gem, the last one we should need to collect. We check, are we blocked? We're not. So we come down into the while loop, and before we call wander collecting gems, we ask, is the number of gems collected less than total gems? No, it's not. It's equal. So we drop out of this while loop to the end of the code, and we're done. All right. Great little program here. Good way to wrap up the variables section. We just to review what we've learned here in this chapter, we learned about making named containers that can hold values. Those are variables. If we want to reassign new values to those containers, it's a variable. If we want them to remain the way we set them at the beginning, they're constants. And constants use the keyword let. So we can say let something like total gems equals some value, and it will stay that way the whole time. Otherwise, we can say variable number of gems collected, assign that to a value, and then later on we can change that value. Like here, we're saying number of gems collected, whatever you were before, add 1 to it. Okay? But perhaps more importantly here, we wrote some nice code here, a very simple main program. This is nice, which just says as long as our number of gems we've collected is less than the total number of gems, we want to wander around this path collecting gems and toggling. And the wander around collecting gems and toggling is just this abstract idea that says take a step forward onto the next tile, check it for gems, check it for switches, and then get yourself ready for the next time you move to a tile by looking if you're blocked. If you are, either turn to the right if there's a path open to your right, or turn to the left if there's a path open to your left. And if neither of those are true, you don't have a path to the left or the right and you're trapped, then turn around. Go back along the path from which you came. Okay? And in there, these ideas of check for gems and check for switches, we put those into nice functions so we don't have to worry about them anymore. The details are all in here, and we can just say check for gems, check for switches, and we know that when we do that, we're checking if we're on a gem, we collect it, and we're incrementing our variable so that it keeps track of the number of gems collected and the number of switches toggled. Okay? All right, hope you enjoyed this one. This is a great review of this chapter and everything we've learned so far. We've got while loops in here. We've got nice functions in here. So if you worked on this code and you're not happy with your solution, or it took you a long time, it's a good place to just pause here for a while, take a couple days, think about it a little bit, and then come back to it. Erase your code, start over from the beginning, and try to write some code you're happy with. It doesn't have to look like this, but as long as you've got a relatively short main program that's very readable, and you've got some functions that abstract ideas away, that's great. You're doing great work. Okay? All right. Good job, everybody. We'll see you next time.